This is my video for Computer Games Design Studio 2 project. On the left is the list of mechanics that I originally had planned for the game, and on the right is the list of mechanics that are currently working in-game on the demo level as seen below. Highlighted in red are the mechanics not currently in. The reason behind different enemy types not being in place right now is that I decided to focus solely on environmental effects this semester before enemy types, and I plan to widen the variety of enemy types and the complexity of the AI in the next iteration of my design. The reason I left out score multipliers in the pickup section is because of a choice I have yet to fully decide on between whether I would have pickups that would increase score for a short amount of time or have the score multipliers work a different way, such as like consecutively killing enemies in order to rack up some multipliers, or have specific enemies that increase score multipliers on being killed. They're each different ways to play the game, and they each force the player to do a different kind of strategy, so it matters a lot which I decide. So I've decided to implement it in the next iteration when I decide and when I get some more variety of enemy types in. I completely cut out the idea of procedurally generating some parts because of my lack of Unreal knowledge. I didn't want to overscope and end up spending too much time on something that's only a portion of the game. And I also completely cut out the idea of smaller rooms because when I was playtesting, the feedback I got said that there wasn't a real reason to having them that affected gameplay. If anything, they made gameplay easier and less fun because it made it too easy having all the random pickups in place. It just made navigating the level longer and had no real interest or reward to the people when I did my playtesting. Of all the mechanics in the game, the four that matter the most to level design and how the player is using all the other mechanics to play the game are the environmental mechanics in each of the four main rooms. Each room has its own special mechanic that the player has to work with or work around, and shown are the possible ideas and concepts I had for each room and which ones I actually ended up using are shown in green. For the server room, I chose wires over lights because I believe that it's fairer to the player. Wires are easier to work around than being completely blind for a few seconds and letting the AI run over you, and it's therefore less frustrating to the player. The wires are also interesting as the players need to change their movement patterns and strategy on the fly according to the wires changing right in front of them. For the gravity room, I chose the centrifuge because it opened up an interesting dynamic. Because they move in a clockwise fashion, players need to move constantly around the room in a circle, looking ahead to dodge what's coming their way, while looking behind them in order not to get caught. But they can't speed up too much and get away from them because they'll hit the lasers. It seemed a much funner and interesting mechanic to implement than the other two. As for the storage room, I originally implemented the conveyor belts, but after finding out that it was too CPU intensive and the frame rate dropped to an ungodly small amount, I decided to put in destruction pits that kill the player upon entry. You can see the remnants of the conveyor belts still in the room. I chose the moving burners for the engine room as I believe that it doesn't just keep the player on their toes and forces them to not stay in one place, but I think it also will fit the aesthetic quite nicely. The joint reason for the gameplay dynamic decision for each room is that I wanted each room to have a different strategy for the player that keep them constantly moving, but in different ways so that no room is exactly the same, but each room is exciting in its own way. As you can see, the level design and layout changed dramatically from the original plan. The original plan, which is the picture on top, was to have large rooms with smaller rooms accompanying the larger rooms, and the smaller rooms were planned to contain specific enemies that react in certain ways that were exclusive to the side rooms, such as a corridor enemy that reacts and moves a lot faster when it sees you. And that went along with bonus rewards for the player if they managed to clear all of the smaller rooms out. However, due to time constraints, I was only able to have the pickups randomly spawn there, and when I did the playtesting, the feedback I got about it was that the smaller rooms were useless and the players were completely uninterested in them. They simply made the level longer to navigate and made the game too easy because the pickups from the small room that automatically spawn there made starting the larger rooms too easy. If I had more time to create the specific enemies and other gameplay mechanics for the smaller rooms, they could have worked out well, but since I'm only one person and I had to focus my attention to the larger, more important rooms, I had to cut them from the game. If this game were to be improved though, that's something I would work to bring back. The design now, however, which is the one on the bottom, is much more conservative and focused much more on the large rooms, which are the main gameplay aspects. The corridors are quick to navigate and symmetrical, and each room is accessible from the start, letting the player attempt any room in any order they want, in any order they see fit. Once I got the level set up, I did some playtesting. The results were what you can see on the screen. Players liked the gameplay and how challenging it was. The weapons are balanced and help the player in tight spots to regain control of the room. And each room is unique in its own right, which is what I was aiming for. However, as I said earlier, players dislike the large amounts of time spent walking between large rooms, and while they suggested ways to make the rooms interesting, the side rooms, I ultimately just ended up cutting them out to save time. He also shortened corridor length to stop the amount of time spent between the rooms. And I changed the controller movement so that player slides less and it snaps to angles easier rather than drifting a lot, which it used to. Of the bugs that were accounted for, I've only managed to fix one so far. I managed to fix the weapons melding and causing players to use multiple weapons at once. However, as for the other bugs, they're yet to be fixed. I plan to fix the health pickup, as that's the main source of players getting health over the max amount. As for the player's spawn being blocked, I know how to fix that, I just didn't get the time. And the weapons not destroying themselves occasionally is a byproduct of my old weapon system, which I plan to update in the future to a much sleeker, simpler, and more CPU friendly system. Now we're going to move on to the technical side of my level using blueprints in Unreal Engine. This is a basic damage blueprint. It contains an area that if the player only overlaps, then the player will take continuous damage by using a custom event and running the event using a set timer by function name node. When the player then ends the overlap, it stops by clearing the timer by handle. The player's health works by having a set value of 100, then whenever an event happens that affects the health, this blueprint calculates it. Upon the condition of the player being dead, i.e. having 0 health, the player loses all input to the character to stop movement and his weapon is destroyed. After a delay of 3 seconds, which is the death animation time, the game then increments the score and life loss from the function in the game mode blueprint, then depending on whether the player has any lives left or not, it either respawns them in the level or sends them back to the main menu. The player is only respawned if they have lives. The player starts with 3 and can pick them up via pickup in the game dropped by enemies. When a pickup is used, the increment lives function adds what is specified to the current lives. If the player does have a spare life, then this function is ran. It spawns the player character at a specified transform, which is set at various times in the level, and has the player possess said character to continue. This is the way the player adds an extra life using the life pickup. Once the player collides with the pickup, it uses this function to cast to the game mode and set the player's lives to +1 of what it originally was. The health pickup works in a similar fashion. It sets off a function which adds health to the player. The weapon changing system is one of the more complicated pieces of scripting. Upon changing a weapon, the weapon select number is changed and a ping is sent to the switch using the weapon ping custom event. This is the original weapon that the character spawns with and will have attached to it at all times, unless it changes. Upon it changing, it spawns the corresponding weapon to the weapon select and attaches it to the player using a socket on the skeletal mesh, where it becomes the primary weapon for 10 seconds. After which it destroys itself, sets the weapon select to the base weapon, and pings the script again to respawn the original weapon. This is how the weapon select gets changed and the weapon script is pinged. The weapon pickup, after verifying that the actor overlapping it is the player, pings the weapon destroy function before changing the weapon select, pinging the script, and then destroying itself. This is the destroy weapon ping, which is used before the weapon select is changed, which ensures that the weapon that the player has equipped is destroyed and not the weapon it just spawned in. The way the weapon actually fires is using this script. Upon pulling the trigger, a custom event function is set off, which continuously loops. Upon releasing the trigger, the looping function is then cleared. For weapons with multiple rounds fired at once, the script is the same, with the only difference being multiple fire functions being used at once using sequence nodes. This is the blueprint for the projectile. On the event that the projectile overlaps with anything, firstly it checks if the actor has the wall tag, which if it does, instantly destroys it. If not, it looks to see if it's using the damageable interface, and then if the actor doesn't have the none tag in order to avoid the player killing himself with his own bullets. Once it's been through those checks and is certain that it's colliding with an enemy, it affects its health using a set amount and then destroys itself. This is the AI that all enemy characters are loaded with. On event begin play, it sets a timer by function name to use the hunt player function, which is just an AI move to wherever the player is. This is the script that causes the enemy to do damage to the player. It's much like the one from earlier, except it's attached to the enemy character. When the player only overlaps the enemy's damage box collision, it runs a custom event which loops continuously until the player leaves the box collision, where the function is then cleared. This blueprint is in charge of calculating death and spawning pickups from enemies. When an enemy's health reaches 0, the blueprint first casts to the game mode to increment the score, much like the lives do. It does this because in the event of the player's death, the correct amount of lives and score will always be shown in the purge blueprint. It then sets both the collision for the mesh and damage box to ignore so that the enemy cannot continue to damage the player. It then detaches the AI from the controller in order to stop its movement towards the player. And then it runs a series of branches. The branches work by picking a random integer, and if that integer is same as the one in the equal box, namely 1, then that specific pickup will spawn at the location of the enemy's death, with each drop having its own spawn rate. There is then a delay of 3 seconds to account for the death animation, and the actor is destroyed. When it comes to spawning the enemies, each room has its own set of spawners. The spawners run this function on a loop. When it's in use, it constantly checks the amount of enemies that are already in the level by getting all the actors from class and then getting the length from that. This is then plugged into a branch node so that if the length is higher than the max enemy limit, which I set, it will stop spawning. If it isn't, however, it will spawn the AI from a class using an enemy character as the pawn and then spawn the actor in a random point in the bounding box it's created in. This is the event that actually spawns the enemies in and continually does so for 1 minute. This is one of the most complicated things to figure out, but I managed to do it. It does so by getting all the room spawners into an array, and then individually gets each spawner using a get node, where the spawners are then plugged into a set timer by function node. The spawn rate is set to increase every 15 seconds by a set amount or to a limit using a branch node. Upon the 60-second timer ending, the timer is cleared and spawning stops. The challenge to overcome here was how to individually get each spawner to run its own function. I'm sure this isn't the most efficient way, but it's nevertheless a solution for now while I test the game. I also struggled in how to increase the spawn rate incrementally and found a solution in a repeating circuit that checks to see if the spawn rate has reached a certain limit, and if not, to increase the spawn rate, wait, and try again in 15 seconds time. This blueprint shows the rotation I added to the centrifuge in the gravity room, which is set to an event tick and to rotate in the Z direction in order to make it spin. And above is how the player's spawn transform is set whenever they enter a room, so if they die in the room, they respawn in it to continue the gameplay. This also sets off the laser function, which is set inside the centrifuge blueprint. In this particular blueprint, once the lasers event is triggered by the overlap on the level blueprint, it fires a do once node which then begins a looping function. This function repeatedly turns off and on the lasers centrifuge by toggling the visibility of the particle and the collision box which damages the player. Every time it loops, it sets a value slightly higher so that after 3 loops the script stops, meaning that this means that the lasers will only turn on 3 times during the 60-second timer, 3 times for 10 seconds each, giving the players an obstacle to dodge in the room and then stopping straight afterwards. This particular blueprint is for the server room. Upon overlapping, each wire in the server room has a repeating function, which every 5 seconds runs a random integer against another. If the two match, then a damage aura and particle are spawned at a wire location, and if not, the script waits and attempts again in 5 seconds in order to randomly turn on and off the wires in the room, creating another obstacle for the player. Finally, this script works for the engine room and uses Matinee to move the engine burners up and down on a loop. The burners are then offset in a zigzag pattern, and while 4 are above and turned on, the other 4 remain below turned off. When the burners are at the top, the script spawns damage auras around them, and when 8 seconds have passed they despawn as the animation plays to change the burners over. Whereas while the damage auras are spawned on the above engine burners, platforms are spawned over the burners that are below ground in order to avoid characters or enemies falling in. This repeats constantly after being set off. In order for the player to progress in the game, they have to complete each room, with each room giving the player a point for completion, and all the points needed to progress into the level. The way the rooms are checked for completion is using this script. Firstly, upon entering the room, a door is spawned behind the player to block exit from the room. Then when the 60-second timer is over and enemies have stopped spawning, 2 branch nodes loop continuously. The condition for each of these branches is that there are no enemies in their level. The way this is checked is getting all the actors from the class enemy character, getting the length, and checking if it's equal to 0. If it is, then the door despawns and the player gets a point for room completion. If not, the room stays locked and the player doesn't get a point. This ensures the player has actually completed the room and not simply cheated. This is one of the hardest scripts to figure out because of how to check to see if there are enemies left. I figured it out though when I realised I could use the same method from the enemy spawner that caps the amount of enemies you can have in order to ensure there are no enemies left. Finally, once the player has completed a room and passed the required checks, a room completion mark is sent. This sets a value to +1 its original number and then sets off the level complete check event, which checks to see if the new value meets the requirement for finishing the level. If it does, then the player sees the center room from the camera and watches the words level complete appear. In future, I plan to have the player step onto an elevator to progress, but this is just proof that the system works. When it comes to the aesthetic, I plan to create the idea that the space stations are very much standard, and infestations are happening all the time as per the setting of the game. The idea for a full game would have space stations with each different aesthetic looks. A company with a red branding and based on mining would be very different aesthetic feel and colour scheme to that of a research space station based on a gas giant somewhere. For the slice of my level, I'll only be focusing on an engineering level, so the intentions of a full space station wouldn't be clear until getting to higher levels. But the rooms will use a blue colour scheme with company logos plastered on the walls for a fake company I plan to create. Since the game is top-down, the models don't have to be insanely high poly, but they still have to look realistic. Each room has their own unique centerpiece as well to model, and that's why there's a mood board for each different aspect of the station. The center room, the corridors, and each of the 4 rooms involved in the level all have their own mood boards. And the way the game looks from the player's perspective, it's like a space station floor with the lid popped off, showing what's inside.